Battery 40%. All righty, it is 1 p.m. Eastern time, so we'll go ahead and get started. Thank you for those of you that are here and live with me today for our AeroSafe weather brief analysis. Starting a new format here to try and help improve consistency and regularity in bringing these weather analysis to you. So as a reminder, my name is Erica Gilbert. I'm a certified flight instructor with instrument privileges based in the Lexington, Kentucky, Central Kentucky area. And here on AeroSafe, what we do is talk about weather from the perspective of a general aviation pilot. This is all to help you better understand weather theory, weather products and charts, and then to take it to the higher level of aeronautical decision making as it relates to weather. Weather is the causal or contributing factor in far too many accidents and incidents. And so the more that we can spend time learning about weather and how to make decisions based off of weather conditions, the more safe you are likely to be, you and your passengers. So that's what we're chatting about. So when it comes to the weather briefing, I am going to use the weather brief checklist as I often do. I created this weather brief checklist to help make sure that everyone is getting all of the really important pre-flight information that they need before they take off. So this checklist is available at gilbertaviation.com/aerosafe. Just pop your email address in there and then we email it straight to you. First page talks about all the pre-flight action that is required, 91-103. And then the second page talks about all the different weather reports and forecasts that you want to be sure that you're looking at. I'm working on a new form of this that actually is going to incorporate a flight risk assessment tool. So keep your eye out for that. So if we refer back to this checklist, one of the first things on the list is the surface analysis chart. So we're going to look at our surface analysis chart first. Surface analysis chart depicts frontal and pressure systems across the U.S. And so this gives us a good idea of what is going on atmospherically, and then we can look at this and determine, well, this is the cause for a lot of the weather that we see, or some of a good portion of the weather that we see across the country. So I like to go east to west because I live on the East Coast. So I kind of start where I live. We've got a low pressure system up here in just off the edge of New York State here. And there's this cold front that's kind of wrapping around through the Atlantic Ocean there. A little bit of low pressure in Georgia, and then a little bit of a stationary front, which then turns into a warm front over Texas and up into Wyoming. High pressure in a lot of the eastern and Midwest region part of the country. Dry line depicted here over West Texas, New Mexico. That'll come up a little bit later. We're going to talk a little bit more about that. Here over Idaho is a low pressure system, and you guys can't see this chart, can you? Nope. Okay. Bear with me momentarily. It went as a pop-up. Here we go. Okay. So now you should be able to see it. Yeah, great. Okay. So we'll start over here. So low pressure up over New York with a cold front moving down over the Atlantic, and then low pressure in Georgia. Stationary fronts, and then in Louisiana it transitions to a warm front coming from Louisiana up into Wyoming. We've got the dry line in West Texas, and like I said earlier, that's going to come up again. We're going to talk about that in a minute. Some cold fronts over here, Four Corners area. And then over Idaho, there is a low pressure system. And then we see a front depicted with a purple line and a semicircle. Now that front is called an occluded front. And the definition of an occluded front is when a faster moving cold front catches up to a slower moving warm front. And that's exactly what's going on right here. We see the warm front and then this cold front. The tail has caught up to it. And so now over this southeastern part of Idaho, we now have three air masses that are stacked on top of each other. And that is often, occluded fronts are often seen at a low pressure, because how does air move around a low pressure system? Well, counterclockwise, primarily, also inward and upward, right? It's rising air. So as this low pressure is creating that counterclockwise motion, it encourages cold fronts to catch up to warm fronts, if that's how they present themselves. We've got troughs over the West Coast, so elongated areas of low pressure or rising air, which is also unstable. I know there are a couple people live in the chat. Does anybody have any questions about anything you see on the surface analysis chart? Okay. I forgot there's a delay. All right, so that's surface analysis. Going back to the weather reports and forecast on the AeroSafe weather brief checklist. Next thing that we want to look at is some of our advisory products like SIGMETs and AirMets. And to do that on 1-800-weatherbrief.com, we can go to map and interactive map. And then while we're on the interactive map, we can turn on the layers and we will look at SIGMETs. So I've got all the SIGMETs on right now and all the outlooks. So we've got convective SIGMET and SIGMETs and convective outlook. Let me just make sure, no comments. Okay, good. So as it stands, it looks like there's only one actual convective SIGMET in the Tennessee, Missouri, Arkansas area. Oh, did I click on the wrong thing? Yes, I did. All right, so we've got a convective SIGMET here. Area of embedded thunderstorms moving from the west 280 at 20 knots, tops up to flight level 420. So lots of convective activity in here, and it's embedded, meaning that those storm cells are within a cloud. So you have no chance of seeing them. The only way to reasonably make it through here would be if you had onboard weather radar, not NEXRAD, not TSB, not SiriusXM, but an actual real-time radar on board. And then that has its own limitations. So best thing to do here would really be to go around it if you're able, or to just wait until it clears out. We've also got convective SIGMETs over the southeast. So these are essentially saying that all the ingredients for a thunderstorm exist in that area. Jennifer West, I see your question now. What are troughs? A trough is an elongated area of low pressure. So similar characteristics that we could expect with an actual low pressure system. There's going to be rising air, which is unstable, so the potential for cloud development and sometimes relatively significant vertical development with a trough. Okay, so that's the southeast. We also have convective SIGMET convective outlook up in the northwest. So same thing, all the potential ingredients exist there for convective activity or thunderstorms. And those three ingredients for a thunderstorm are lifting action, unstable lapse rate, and sufficient moisture. So the Aviation Weather Center has issued these convective SIGMETs, saying that it's very likely, very possible that we might see some convective activity in that area. So as it stands currently, if you look, both of these areas are severe VFR. All of these METARs, all of these reports. So for example, Talladega, we've got light winds, clear skies, 10 miles of visibility, and continues the TAF is continuing to say the same thing. But that goes to show you that a METAR or a TAF doesn't tell the whole story. There's still the ingredients for convective activity going on here. And if we refer back to the surface analysis chart, a lot of that's going to have to do with this cold front here. As it moves, cold fronts come in kind of like a snow plow, and they push warm, moist air up, creating instability, creating clouds with vertical development. And oftentimes some of the worst weather we see is associated with cold fronts like that. So it'll be interesting to see what happens there. As for that convective SIGMET up, or the convective outlook in the northwest, let's see, it probably has a lot to do with that occluded front there, is what I would say. That would be my guess. All right, so moving back to the weather advisories, we will turn off the SIGMETs. Well, so big takeaway here is I would stay away from that convective SIGMET over West Tennessee, Arkansas, Missouri. Definitely be very mindful of what's going on and how that little storm system is moving. And then where those convective outlooks exist, there's a lot of VFR weather there right now. So just be mindful, look at the TAFs, look at the forecast discussions at those airports, and make sure that you really understand what's going on and what the trend of the weather is going to be. Sometimes a TAF, a terminal aerodrome forecast, won't tell the whole story. TAFs are written by meteorologists at the local National Weather Service office, and sometimes they confidently know that convective activity might take place. They just aren't exactly sure the window of time. So while they may not have a line in the TAF that shows convective activity, it may be listed in the forecast discussion. So always make sure you're reading the forecast discussions to make sure you've got the full story. All right, SIGMET's off, AirMet's on. We'll start with Tango. AirMet Tango, T is for turbulence. AirMet Tangos also include sustained surface winds of 30 knots or greater and low-level wind shear. So the 4 different AirMet Tangos you might see are low-level turbulence, high-level turbulence, low-level wind shear, and sustained surface winds. And we have a little bit of all of those today. Up in the Northeast, we have low-level turbulence from the surface to 10,000. I'm going to go ahead and skip ahead a little bit. Let's turn on some PIREPs, see if we see PIREPs in that area. Wow. When they are outlined in red, that means they're urgent. So I'm thinking that not only is there moderate turbulence, but something a little bit more. Okay, low level wind shear here, plus or minus 10 knots, runway 24. Is that urgent? We've got an urgent also for low level wind shear, plus or minus 15 knots. And a Gulfstream 5 with moderate turbulence, low level wind shear and moderate turbulence. If a Gulfstream is reporting turbulence, it's very likely pretty good turbulence for us. Another turbulence PIREP, urgent PIREP. This citation is experienced low level wind shear plus or minus 20 knots from the surface to 3,700 feet during descent to runway 4. That is a pretty big change in airspeed that close to the ground. Another urgent PIREP for low level wind shear, minus 20 knots on final. I'm seeing a trend, low level wind shear, low level wind shear, low level wind shear. Okay, and low level wind shear. Cessna 206. Very interesting to me that there's not a low level wind shear AirMet here, given how many PIREPs we have for low level wind shear. That is really interesting. Big picture here is that it's really bumpy up in the Northeast. So that kind of looks like an area that I probably wouldn't want to be flying today between low level wind shear and the turbulence. Turn the PIREPs off for now. Up in northern Minnesota and a little bit over the Dakotas, we do have a low level wind shear AirMet. Now, low level wind shear, we're going to turn on the PIREPs again. Low level wind shear is particularly dangerous because we're operating close to the ground. And as you saw with those pilot reports or PIREPs, there can be a dramatic change in airspeed. And particularly when we are configured to land in light piston aircraft, our final approach speed is 30% higher than our stall speed in the landing configuration. That's how they determine our VREF or final approach speed, 1.3 times VSO. And so for most of us, stall speed, landing configuration, light piston aircraft, probably 45 to 55 or 60 knots. If you add 30% to that, we're somewhere in the 70 to 65 to 80 knot range. And so a loss of 20 knots when you're already that close to stall speed could be pretty significant. And it could be the difference of flying and no longer flying or being stalled. So, very significant and potentially very dangerous as well. Add to that turbulence, and it's not only uncomfortable, but also dangerous. Just looking at the PIREPs here in Minnesota. Icing, no icing. Sky's overcast. Okay, so low level wind shear air met here, though there are no PIREPs to support that. Over Colorado, New Mexico here, we have both high level and low level turbulence. Basically, from the surface all the way up to 38,000 feet, you're likely to experience some turbulence. There's also low level wind shear over Colorado, and we've got PIREPs to support that. So here we go, CRJ 200. Low level wind shear plus or minus 10 to 15 knots, plus 15 minus 10 knots on final for runway 16 right. And PIREPs, Falcon, moderate turbulence, 18.5 and 190. Mountain wave turbulence plus or minus 10 to 15. Light chop. Low level wind shear. Now, why didn't that one get outlined in red? Like an urgent. Don't know. High level turbulence stretching from Idaho down to Southern California, and then low level turbulence surface to 12,000. With PIREPs to support that. Yep. Okay, so based on the AirMet tangos today, I would want to stay out of the Northeast, even though it looks pretty nice in VFR through a lot of that area. What are the ceilings? Ooh, girl, it's windy. Wow. Montgomery, New York. That's New York, right? Montgomery, New York. 310 at 13, gusting 30. Peak wind 310 at 34. Pretty strong. So yeah, I probably wouldn't be flying up in that area today. What does Elmira say? Also very windy. So honestly, with wind gusting that strong, it's no surprise that there's low level wind shear and turbulence. It's kind of a given. So stay out of the Northeast today, given the surface winds. That's outside of my personal minimums for a light piston aircraft. And then over Colorado with the low level wind shear, mountain wave, and turbulence, I'd stay out of those as well. Switch over to the AirMet Sierras. This is AirMets issued for widespread areas of IFR conditions, or if it's IFR over mountainous terrain, then it's mountain obscuration. Far up in the Northeast, we have both IFR and mountain obscuration. So when it comes to IFR, obviously you need to be current and proficient to fly under IFR. If you don't have your instrument rating, you've got to maintain VFR weather minimums, right? So class echo under 10,000, 3 miles of visibility, 500 feet below, 1,000 feet above, and 2,000 feet horizontally away from clouds. You've got to maintain that. Further up in the Northeast, it'd be maybe a question of what is the freezing level. If you're in a cloud, if you're in visible moisture and temperature is at close to or below 0 C, very likely that you'll pick up icing, structural icing. Most aircraft that we're flying are not certified for flight into known icing, though some of you may have it. So you'd want to be very mindful of, are you going into icing conditions? Is that within the capability of your aircraft and of you as a pilot? Have you flown in it before? Have you used it? Do you fully understand the limitations? So up there, probably stay away from that. Well, what is the freezing level up there? Freezing level is 4,000. So yeah, given that there is mountainous terrain, freezing level is only 4,000 feet above the ground, and there's clouds, IFR, widespread IFR, and the low level wind shear and turbulence. That's definitely an area that I'd want to not be flying in a light piston. Right through the middle of the country, we have a huge area of IFR conditions. And we've got the air met here, and I also have the METARs turned on so we can see the flight categories. And yeah, it's pretty in line. We see marginal VFR, we see IFR flight categories, and low IFR categories. So yucky stuff in that area. Same thing here. You would need to be instrument current, instrument proficient. However, freezing level is at 12,000 feet. So this would probably be a pretty good area to work on some instrument training, to do some instrument approaches, to maintain currency if you're already current, or to go up with an instrument instructor and practice some of that. Here's a pirate, probably just tops at 4,300. So beautiful. That is just perfect IFR day, in my opinion. Get up above the clouds, get to where you're going, come down through the clouds to fly an instrument approach to get down through the clouds, and then have a really nice productive day, build some proficiency and currency. It's really good, really good. California, Nevada, and up in the Pacific Northwest, we've got Mount Obscuration and some IFR air met. There are icing pyreps at 8,000 feet and a DA-42. I do not know if a DA-42 is Fiki. Is it Fiki? It is Fiki. Well, that's cool. I didn't know that. So then as long as they have their TKS fluid, they should be fine. -1 degree. Another pirate here for icing. Light rime between 9,000 and 1,000 in an Airbus. So freezing level in that area is 8,000, and we've got some pockets where it's kind of variable. That might be a little close for me, especially flying flying IFR. I was looking at this area recently, and a lot of the minimum en route altitudes are pretty high, like 7, 9, 10, 11,000 feet. Not even to mention the ORACAs, the off-route obstruction clearance altitudes. Those are the altitudes if you're flying a GPS random route direct to your destination. Super high altitudes, minimum altitudes there to stay above the terrain. So if you are in clouds at those altitudes, you're going to pick up structural icing. And the question then again will be, are you certified for flight into known icing? Is your aircraft capable? And are you proficient and knowledgeable in the operation and limitations of that system? Okay, so based on this, and we already ruled out the northeast part of the country because of low level wind shear, turbulence, and now we're adding icing into the mix. Holes in the cheese are definitely lining up there. Wouldn't want to do that. This middle part of the country, from North Dakota down into Oklahoma, if you're instrument rated and winds are within your limitations, let's see, what is this? McConnell Air Force Base. Well, you're not going to be able to find it out there, but wind is reasonable right now. Ceilings are a little low, so me personally, I do not like to take off with a piston into less than 1,000-foot ceiling. However, we do see the TAF is saying becoming at 1,400 Zulu to 1,500 Zulu, thunderstorms in the vicinity. VCTS. VC is vicinity, TS, thunderstorms. Broken at 700, overcast at 1,200. cumulonimbus. So weather's going to deteriorate there and deteriorate quickly. What about Omaha? Epley Field. 150 at 16, gusting 16, overcast at 1,000, right at my personal minimums. Gusting to 23. Ceilings are forecast to come down. When is forecast to get stronger? Visibility comes down with mist. So, Nebraska, lots of wind. And ceilings coming down. Temporary for a time. 3 miles visibility, mist, overcast at 200. Makes it low IFR. So, I did say, as it stands right now, some of these areas might be good for instrument currency and proficiency. However, depending on where you are and what your plan is, there are other hazards that exist right now in this area. There are, absolutely. And the weather is supposed to deteriorate even more into tomorrow and Tuesday. West Coast over here, same kind of issue as the Northeast. There's mountains, there's IFR, there's some turbulence. And to fly safely under instrument conditions, if you're in the clouds, you've got to be at a really high altitude, and that altitude is above the freezing level. So now we're mixing visible moisture with temperature at the freezing level or below freezing, and that's a recipe for a no-go decision. Make sure there's no questions. Okay, great. So last AirMet to look at is going to be Zulu. And no surprise, we've got AirMet Zulus over all those areas that we talked about already. Add to it Michigan, Minnesota. Freezing level between 7,000 and 11,000. And then over the convective stuff here, which you're not going to be flying through anyway. Oh, excuse me. You're not going to be flying through that convective stuff, but if you were, and you were within the dimensions of the AirMet, so 11,000 up to 21,000, very likely that you would encounter ice. Montana sweeping down into California. AirMets, Zulus as well. Bases at 8,000. Base at the freezing level 6,000 to 8,000. So, yeah, I'd stay out of those areas today. All right, we'll glance at center weather advisories here quickly. The panhandle of Texas, we've got a center weather advisory for near the Amarillo area, occasional low IFR conditions, ceiling below 500 due to fog. And the METARs reflect that. Pampa, 2.5 miles of visibility, mist, overcast 200. Amarillo, 5 miles of visibility, mist, overcast 200. That was a special observation. One other center weather advisory down in southwest Idaho, area of embedded thunderstorms. So why is that a center weather advisory instead of a SIGMET? The only reason I could think is that an AirMet or SIGMETs, AirMets at least get issued when there's at least 3,000 square miles of affected area. I do not know the criteria for a center weather advisory, but that's what we got. So low IFR, again, I don't like low IFR in pistons. And then convective activity, obviously, we got to stay away from that. Severe weather warning and watches. I don't see any as of yet, though there will probably be a lot as we get some really good convective activity going on in the Midwest. Any questions? Nope. Okay. Okay, we looked at SIGMETs and AIRMETs and PIREPs, and freezing levels. We can look at cloud coverage next. So I will pull up the weather charts, and this actually, Flight Service recently changed this. They used to pull up the chart for you. Now they give you a link to the Aviation Weather Center, and to get the clouds, we've got to click the graphical forecast for aviation. This is a forecast, so it's not current, it's only modeled output information. We'll do the whole US, and I want the cloud chart. Okie dokie. This chart confirms a lot of what we already know, a lot of what we've already seen. That is, up in the Northeast, we've got icing, mountain obscuration, and clouds. We've got lots of clouds. Some of the tops are pretty high there, up towards the border with Canada, flight level 280, 250. Yep. And then we've got a portion of the east that has effectively no clouds or cirrus clouds. Up through that central corridor of the country is where we see a lot of that IFR stuff that we talked about. We've got fairly low overcast ceilings, not super low. In North Dakota up there, we've got overcast at 2,000, broken at 4,000. And then the tops are pretty low, so pretty stable air here. And this is kind of some ideal conditions for that instrument proficiency and currency, should there be no other hazards. But if we go back to the map and we look up at North Dakota, Jamestown, wind is 180 at 17, gusting 27, overcast 800. Peak wind 170 at 27. That's pretty strong. Ceilings are forecast to come lower, thunderstorms, cumulonimbus clouds. So things are definitely going to deteriorate. Bismarck, 10 miles, visibility 180 at 9, overcast at 1500. Again, cumulonimbus in the forecast. So if there were no convective forecasts, probably would be a pretty good time. But anytime I start seeing a cumulonimbus in the forecast, that makes me not want to fly. Let's see, Cameron, Aviation Weather Center can only issue convective SIGMETs at 55 past the hour. Center weathery for thunderstorms tends to cover. Okay, great. That's great to know. Thank you for sharing that with me. Mark, weather briefs. Is there a legend to decode the equipment on aircraft? That depends on, well, you're talking about ICAO surveillance equipment and navigation equipment, I would think. There is a pretty good guide. Well, let's see. If you go on Flight Service to account an aircraft, you can add an airplane, and you can get some help with the aircraft equipment. So if you if you click aircraft equipment, you can see what all the different codes mean. So this is our surveillance equipment, right? So our transponders. No, that's the FAA equipment. This is the ICAO equipment. We'll tap the magnifying glass, and then we can see what the codes mean. So for most aircraft, we would select S for standard, meaning you've got VOR receivers, very high frequency radios, and ILS. If you have a GPS receiver with WASP capabilities, then you'd select B for LPV, approach with vertical guidance with satellite-based augmentation system. You'd also want G for GNSS, and R for PBN approved. And cool, you got it. There's also, if you use ForeFlight has really great guides that also kind of talk you through what these different equipment codes mean. Then the best part of this is if you go down to the bottom, then they list equipment codes by your hardware or your receiver that you have. So for example, if you had a Garmin 430 with WAS, you would select R, B, and then your PBN codes would be C2, B2, C2, D2. I should probably switch. There we go, so that the screen's bigger. We'll get there. Okay, back to the cloud coverage. Yeah, this central part of the country where there is convective activity that is expected to take place, I probably would just stay out of that and I'd wait a little while. And then the west, we already talked about that. We've got areas of low level wind shear and turbulence, had a report or two of mountain wave, and we've got mountain obscuration, IFR, and icing. So, kind of effectively for me, when I look at this, most of the places that we have clouds today are places that I would probably want to stay away from. There you have it. All right, so we looked at PIREPS, cloud coverage, freezing level, winds aloft. Now, of course, we would want to look at winds aloft to help determine what our ground speed is going to be and also what your wind correction angle would need to be. And that's going to help you determine how far you can go based on the fuel you're able to carry with your weight and balance. That is really important, and not only do we need to calculate it before time, but we need to be constantly monitoring it as well. So monitoring your fuel flow, if you have an instrument that shows you your fuel flow, and then monitoring your fuel quantity. If you're flying an aircraft with a fuel totalizer, you want to compare those values because they don't always talk to each other. So you want to make sure, again, that you've done your pre-flight preparation appropriately so that you understand your ground speed, your fuel burn, and then you want to monitor throughout the flight. Make sure that nothing has changed to reduce your expectations. Okay, so we came back here for a reason. Winds aloft. These are the kind of things that I normally edit out. This is being displayed differently now than it used to be displayed. I'm not sure that I like this. It used to be different. How do we make it to the way it was? Oh, this is the one I want. Yeah, okay. Turn this one off. All right, so I've got the winds aloft on off of the graphical forecast for aviation down at the bottom of the layers here. And let's select 9,000 is pretty good. I don't really like this layer. Can I change the opacity? What is this? I really wish I could change the opacity. Let's see. I might just go here. Can we get winds aloft from here? This is the same darn thing, isn't it? I really do not like this depiction. But it's what we've got to work with, I suppose. Okay. So over in the east, up in the northeast, we've got really strong winds at 9,000 feet from the north. And it's going counterclockwise up here. So what kind of weather system do we think exists up there where the wind is rotating counterclockwise around the tip of New York? Low pressure. There she is, creating that counterclockwise rotation. It's really cool, I think, when all these things come together. And then we have in the Great Lakes area some high pressure as well, and that is shown with the rotation of the wind. It's mostly clockwise here. But you're going to be staying out of this area because of all the hazards associated over there, and really strong winds tell you that something's up. At 9,000 feet, that's kind of crazy. Very strong winds in the central part of the country. So 35 knots here from the southwest. Everywhere else is pretty light at 9,000 feet. But where the wind is heavy, we do see some of the biggest disruption in weather. And so there is a correlation there. Yeah, Jennifer, you got it. Good. Yep. Okay, so winds aloft at 18,000 feet. We have a really pretty deep trough right here. That's creating that low pressure that we saw earlier. And then the wind speeds up over here. Really creating a lot of low pressure and pulling up a lot of warm, moist air up here, which is what's going on. That's why we're getting a lot of this activity, and that's going to be coming in the next couple of days as well. So it's going to be really bad, really yucky up here the next couple of days. If we were to look at the weather charts again and look at the thunderstorm forecasts, 12-hour and 24-hour, we get a little bit of support for that. That is not the one I wanted, actually. It's not the one I wanted either. Oh, this is the one I want, the severe weather outlook. So going into tomorrow, they're saying that there is up to a slight thunderstorm risk through that central part of the country. We've got general throughout the southeast, upper central part, and over into Idaho. So that's going to be bad weather in general on the surface, but also for aviation inherently. Switch that over to the next day, the 2-day, and it gets even worse. So they're saying moderate, and that's even 2 days from now, up in the Midwest, northern Midwest, Wisconsin, and Minnesota area. So really bad weather up there. That expecting tornadoes and really bad weather in the area. Yucky, yucky, bad, bad. So not only is that going to be really bad area for flying, it's also going to be rough area for just in general on the ground. So they are forecasting tornadoes, straight line winds, really, really unfavorable conditions for life and property to begin with, let alone aircraft in the sky. Referring back to the weather brief forecast, we looked at winds aloft. The area where winds are strongest, where I'd want to look out for it, are also areas of inhospitable weather that I wouldn't want to be flying in. So I'd probably stay away from those areas. But of course, you want to look at your winds aloft area winds aloft information and the temperature aloft, because that's also going to give you information about your cruise performance, because we're always comparing our performance to the aircraft's performance at international standard atmosphere. So we want to see our deviation from ISA. Aviation surface forecast, that goes back to the decision support graphics. Again, they changed this recently. This used to open up a new tab, and now we'll go to GFA 3 hours from now, US, and now we want surface, SFC for surface. This chart comes up a lot on check rides, and if you haven't seen it before, you want to look at it and figure out what it means before you go to a check ride. So this chart tells you about all of the weather, or a lot of the weather that you might experience on the surface, from surface winds, including gust factor, to visibilities, flight category, and precipitation, and then also areas of IFR, or freezing on the surface. So the shaded areas, like over here in Nevada, are visibilities on the surface, and these correlate to flight category. So, for example, the blue shaded areas are marginal VFR, so 3 to 5 miles of visibility. The red is IFR, so 1 to 3 miles of visibility. And then the purple is low IFR, magenta, so less than a mile of visibility. Let's see. Oh, we also have the high surface winds. AirMet is on here. And then these money signs are dust. So dust storms in that area, which would make sense given what the geography and topography is like here. If there's really high surface winds, you're likely to get a little bit of a dust storm. Now, these wind barbs can trick people up sometimes. I like to remember them like they're an arrow. So the fletching on an arrow, the feathers are always on the back side of the arrow. They help guide the arrow through the air and fly nice and straight. If you think of the wind barbs the same way, you can kind of imagine you pull a bow, release the arrow, and then the tip is the direction the wind is going to. The barbs, or the fletching, show you just how fast the wind velocity is. So on this one, for example, where my mouse is, we've got 10, 20, 25 of steady wind, and then the red barbs show the gust factor. So 25 gusting 35. Pretty strong winds there. These little red symbols indicate thunderstorm, and then the color is depicted at the bottom. They show the chance of thunderstorm, or the coverage of the area. So the lighter the red, the less coverage of that area they're expecting. The depictions of the precipitation or surface conditions come from the NOAA imagery legend. You should be able to find that in whatever electronic flight bag you're using, whether that's ForeFlight or Garmin Pilot, or let's see, I have an English friend who just showed me the one he uses when he's doing grass strip country flying out there. Sky Demon. I'm sure it's in there as well. So this chart really supports everything we pretty much already said. I wouldn't want to be flying in the Northeast. Really strong winds through that central corridor, where I had said it'd be a good day to do instrument currency and proficiency, but the wind takes away from that, given how strong it is. So you'd have to assess, is it within your personal minimums, and just how far out are those, is that convective activity, those thunderstorms, supposed to take place? Dust storm, probably wouldn't want to fly in a dust storm, because especially the dust storm is caused by that really high wind. Thunderstorms over here, a little bit of snow, don't want to fly in snow. Yeah, so this chart, usually by the time I'm looking at this chart, it's just supporting what I've already kind of figured out. But you do want to look at this and be familiar with it. Going back to the weather brief checklist, METARs and TAFs. So we already looked at several of those. kind of for supporting information for the big picture stuff. And then we also kind of zeroed in on some of those a little bit as well. Like in that central corridor from North Dakota down south, we looked at a couple of the airports to see, would it be a good day to go do instrument proficiency flying? And based on those high level surface winds, probably not. The TAFs are also important because they give you an indication of how the weather is going to trend. And like I said before, you do not want to neglect the forecast discussions. Okay, I don't necessarily want this for Tampa Bay. So this is the area forecast discussion issued by the National Weather Service, Tampa Bay. So I'll just show you what it looks like. So the aviation one is the one that we will typically look at. So for Tampa Bay, they say VFR conditions expected throughout the forecast period. Light southeast winds early this morning will shift to westerly, increase to around 10 knots this afternoon. Sea breeze moves inland. Winds will diminish and become light east to southeast later this evening and overnight. Now again, I don't really want... I just go to this. And then I want to see one for South Dakota forecasts. Forecast discussion. Elevated instability could lead to isolated severe and locally heavy rain tonight early into Monday morning. And where's the aviation? Aviation. Marginal VFR and lower stratus continues through late morning Monday. Strong southerly winds prevail with gusts to 30 knots at times. If gusts diminish, we may see some brief low-level wind shear across the area as the southerly low-level jet increases. However, we've omitted mention given the expectation that gusts will continue. So this is what I was talking about earlier, where you might get Aviation Weather Center has a forecast discussion. Thank you, Cameron. I normally access it just through ForeFlight, so sometimes navigating for this information in other formats can be tricky. But anyway, this forecast discussion kind of shows you what I was talking about earlier, where there may be things that are not in the TAF because there isn't enough confidence either about the timing or about the actual probability of certain weather happening that they don't put it in the TAF. Further example here, a couple of periods of showers and thunderstorms are possible through this forecast period. High-res guidance is struggling with timing and development, but tried to narrow the TERSA periods as much as possible. TSRA. What is that? Thunderstorms with rain. I should have known that. Showers look to be more isolated in nature, so did not give mention given low confidence in timing coverage. An isolated strong to severe storm is possible with the greatest risk after this forecast period. So if your level of comfort and familiarity with weather products is just looking at METARs and TAFs, you are really neglecting a lot of information, especially as things change and the atmosphere warms up going into summer. The jet stream moves. There's a lot of stuff that goes on that they might not put in a TAF, or that you might not see on a radar, but are likely to pop up. And if you read these forecast discussions, it will really enhance your understanding of what's going to happen and give you more confidence in that as well, and help you make more safe decisions. So the last piece that we would want to look at would be calling 1-800-WEATHER-BRIEF to talk to a real person. These briefers are trained on the weather, I don't know to what extent, but for aviation in particular. And so you can ask them questions and kind of pick their brain a little bit, figure out where you might have holes in your weather briefing and where they could fill that in for you. You always want to do that. I would also highly encourage everyone to, there's a notice of proposed rulemaking to get rid of the remote communications outlet for flight service station so that we can call and get weather information in the air. This is a really important piece of safety for decision making while we're in flight, especially for longer flights. I've used it before personally. Contacting flight service station in flight allowed me to divert from my destination, which had thunderstorms over the top of it. I didn't have any onboard weather reporting at the time. So I think it's important that we keep these pieces of information and these pieces of our infrastructure in place. So if that's something that you're also interested in keeping around, I'd encourage you to go write a comment on the notice of proposed rulemaking, just stating your thoughts and your feelings, maybe sharing a story about if you've used flight service before. Alrighty, we have come up right upon an hour. I'll share with you tomorrow. I'm flying the TBM from Naples to Lexington. So normally when I'm doing my own weather briefings, I use my electronic flight bag just because it's a format that I use a lot and I'm familiar with. And we're going to be leaving tomorrow. So some of the stuff that I would be looking at, we've already kind of looked at already. And it is a little far out, being that it's about 24 hours out. But some of the biggest things that I would be looking at would be the surface analysis and the prog charts. So looking at this, as of right now, we've still got this cold front kind of over the area. My biggest concern would be what's going to happen with that cold front and the convective sigmet that we looked at or the convective outlooks that we looked at over the southeast, and this convective activity over Arkansas and Missouri. So to help me make decisions with that, what I would do is go to my weather charts and look at the surface prog charts. This is going to give a good idea. So this is 12 hours from now. There is a chance of thunderstorms over Georgia and southern Alabama there, because that cold front kind of turns into a stationary and lingers a little bit, and low pressure and troughs. So lots of rising air, lots of chance for vertical development, and then the air is plenty moist because it's more moist air from over the Gulf here. 24 hours from now, that convective chance moves a little bit farther east. So in my head, I'm kind of thinking, and that's the biggest concern that I see. There's a warm front moving northerly, but I'm not seeing a whole lot of precipitation planned with that. So in my head, it's a little too early to be looking at advisory products like AirMets and SIGMETs for 24 hours from now. But seeing the biggest concern here is this convective stuff. So my thoughts as I'm looking at this are maybe what I'll do is plan to go a little bit west up through Alabama a little bit versus what I would normally do is as direct as possible, of course, as we all want to. And then thinking ahead to tomorrow, I'm going to be curious to see what's going on with the warm front, if there's any adverse conditions that are created as a result of that, and then this trough as well. While also being mindful that there's really bad weather, really insanely bad weather going on over northern central part of the country, northern Midwest. So 24 hours out, that's kind of my thought process. That's what I'm looking at. And let's see what's going on 36 hours. Okay, so not a whole lot of difference between 24 and 36 hours in terms of what would be affecting my route of flight. So Oh, you guys didn't get to see the prog charts, did you? Golly bum. I have to remember that I'm not sharing my full screen. I'm sharing this one window. Okay. So here we go. Here's the prog chart. The one 12 hours from now, issued at 15:45. So an hour ago. Is that right? Hour and a half ago or so. So not leaving in 12 hours, leaving closer to 24 hours. And so this is what I was looking at that you couldn't see earlier. That cold front has kind of moved down, turned into stationary, and then that warmer, moist air has now taken over and is pushing farther north. So now it's turned into a warm front. So this convective stuff is moving easterly. So my idea is that in route planning, I could look at going flying a little farther west. And then what I'm going to look at tomorrow specifically will be advisory products like AirMets and SigMets. And then looking at to see if this warm front and this trough are creating any adverse conditions that the advisory products would chat about. And then of course PIREPs as well, and all the other stuff that goes into a normal weather briefing. And then before I take off, call a weather briefer. Okay, so that covers the AeroSafe General Aviation weather briefing for today, April 27th. Does anybody have any questions, or does anybody have an area of the country they want me to dig into a little bit before we say goodbye for the day? While I wait for any questions, I just want to remind everybody that you can get this weather brief checklist at gilbertaviation.com/aerosafe. And be sure to keep an eye out because, again, I'm working on an updated format of this weather brief checklist that asks you a little bit more specific questions and then also incorporates a flight risk assessment tool. And you can add in your personal minimums and compare those to what you're seeing, and then also add additional risk assessments in like currency and other hazards that might be involved, like nighttime or mountainous terrain. So I don't see any questions popping up, so I hope you guys have a great rest of your weekend, a wonderful rest of your weekend, and look forward to seeing you next week. Same bat time, same bat channel.